all these questions are based on past exam paper questions, etc., etc. All right, so let's jump in and go and have a look at this. They tell us in the diagram below, we have the graph of f of x equals ax squared is drawn in the interval x is smaller than or equal to 0. Okay, so that is our restriction. What they've done here is they have restricted the domain to where x is going to be negative, right? Because remember, we have to restrict the domain when it comes to a quadratic function because the inverse of the function is not a function. All right, so the graph of f is this one over here. I'm just going to highlight that in yellow so that we can see the difference between f and its inverse. The other thing that they've told us is that the graph of the inverse is drawn. Let's highlight that in a different color. So we'll make that one pink. Oopsie, there we go. All right, and then they've also given us the point P, which lies on F, and R is a point on the inverse. Let's go and have a look at the questions. The first one that they ask us, and you can see why it was so important for us to do that lessons on, is it a function or isn't it a function? Because there's 2 marks. In 4.1, the first thing they ask us, is the inverse a function, and motivate your answer. So it's 2 marks because you'd get 1 mark for your answer, yes or no. And then the second mark would be for your reason. Okay, so I'm not going to tell you guys. I'd like you to tell me what you think the answer to 4.1 should be. Is the inverse a function? And why do you think what you do? Is there anybody who wants to unmute and share what they think with us? Sure, Lusanda, go for it. You're welcome to unmute.
Hello, ma'am.
Hi, Lusanda, how are you?
I'm good. How are you, ma'am?
I'm cool, thank you. Go for it.
I think it is not a function because it cuts the graph twice. It cuts the horizontal line twice.
Okay, so Lusanda says no. Okay, is there anybody that agrees with Lusanda? Or do we disagree? Okay, so let's have a look in the chat. Okay, so Nolwazi says, yes, it's a one-to-one function. Sharon says, yes, it is. Latani says, yes, because it's one-to-one. Interesting. Okay, I see somebody else has put their hand up. Oh, I was going to ask that person to speak. I don't know where they've gone. All right, it is a function. Quite right. Okay, so Lusanda, it is a function. All right, your classmates are correct on this one, right? We've restricted the domain of the original function so that the inverse can also be a function. So here we were supposed to say, yes, it is a function. And there are a number of reasons why. Okay, so there we go. Una says vertical line test proves it's a one-to-one function. Absolutely. So it's a one-to-one function. Or the other thing that we could say as a motivation is that it passes the vertical line test. Okay. So any of those will do. Tsechofatso, do you want to ask something or say something?
I want to ask a question, ma'am.
Sure, go for it.
So in question 4.1, if they say is it a function, is f minus 1 a function, is it possible to get a question like that and then it says motivate your answer by calculations?
Okay, not by calculations, no. Okay, so in certain situations, we have to motivate our answer by a calculation. But here, no, there wouldn't be a calculation that they would expect from us in order to motivate our answer. This is purely a theoretical question. Okay.
Okay.
All right, no problem. See somebody else put their hand up. Faheen, do you want to ask something?
Ma'am, can you just explain what we're doing now? Because I wasn't by my table for a few minutes. I got up for something. Can you explain?
We're just looking at this. We're just looking at this particular function, so you can take a screenshot of that, and its inverse. And we've just answered the first question, so you really haven't missed much. Okay, so the
Yes,
first
ma'am.
question just asked us whether the inverse was a function and we had to motivate our answer. Okay, so you haven't missed anything at all. All right, let's go on to the next
I
thing.
needed to put it to
So
the key. There we
that's
go.
fine. There we go.
Thank you, ma'am.
Pleasure. So 1 mark for yes and another mark for a suitable motivation. All right, question 4.2. They've now asked us to write down the coordinates of R if R is the reflection of P in the line Y equals X. So anybody, would you like to offer an answer for the coordinates of R, please? What do you think they should be? What are the coordinates at R if it's a reflection of P in the line Y equals X? Any ideas? Remember when we reflect over the line y equals x, what was x becomes y and what was y becomes x? That's a little hint.
Ma'am, is it -12 and -6?
It is indeed. Well done. Who said that?
Ooh,
Palestine.
Oh no, sorry,
Palesa.
Palesa.
Well done. Very good.
Sorry,
Perfect.
Palesa. I saw
Okay.
Zis's hand because if you don't raise your hand, we don't see your hand. Sorry,
Oh, okay.
Palesa. Well done.
All right, there we go. Perfect. And I see there's a whole bunch of people that have put in the same answer as you as well, Palesa. All right, very nice. So there would just be 1 mark for our answer only. Okay, looking good. We've got 3 marks so far. So now 4.3, they've asked us to calculate the value of A. So if we just go back up here, A is the coefficient of the x squared term. All right, so I'm just going to write that down. So that's here in front of us. So f of x equals ax squared. So that's the A that they're asking us to calculate. Omaholo, you got a question?
Afternoon, ma'am.
Good
I was
afternoon.
asking
Go
if
for it.
they say we should calculate to show how did you get the coordinates of R. So how do we
No.
do it?
No, there's no calculation that's required. It is an answer that it's only something that you can write down. It's only out of 1 mark. So the hint here was that P and R are a reflection of one another over the line y equals x. So what that means is that we need to use P's coordinates to get R's. Okay, so what the others did is they made what was the x coordinate the y coordinate and what was the y coordinate the x coordinate. That's where it comes from. Okay, Umkholo?
Yes, ma'am.
Okay. Good stuff. All right, now we need to calculate the value of A. Now, this is not a matric questions, a matric question. The other 2 were, but this actually takes us all the way back to grade 10 when we first started doing the quadratic function. Okay, one of the things that we were expected to do back then was to calculate the value of A. Before we do this, I want to ask you, what sign should A be? Should A be positive or should it be negative? And how would we know? Can anybody answer that question? Should A be positive or negative? Okay, why, Nhlanhla? Siamtanda, you said positive. Why should it be positive? Sindiswa, you're welcome to unmute and speak.
I think it should be positive because gradient always be positive.
Okay, so if we go back to grade 10, all right, a graph with a positive A value has a smiley face, right? But graphs with sad faces, or that are sad faces, have got, so here the value of A, should be positive. Here the value of A should be negative. So this arm that you're looking at over here belongs to this function that does that. Okay, so that's where it comes from. So A should very definitely be negative in this case. All right, because it comes from a sad face parabola. Quite right. Okay, so that helps us in terms of our answer because we need to know, we've got to have an idea of whether our answer is correct or not before we even start working. Okay, so how are we going to solve for A? What are we going to substitute into f of x equals ax squared? What are we going to sub in? Zintle, go for it.
Hello, ma'am.
Hello.
Can you not substitute the coordinates of P?
Absolutely. So where should I put the negative 12, Zintle?
Oh, the negative 12 would be for the value of x, which is for x squared. And then the negative 6 would be the value of f of x, which is y.
Okay, so what you've done there, Zentley, is just a little mistake, is you've switched them around. Okay, remember, this is your x coordinate. Your x coordinate always comes first and your y coordinate always comes second. Okay, so that means it's okay, my darling, no stress. Okay, so the negative 12 should go here by the f of x in place of the f of x. And in place of the x, that's where we should put the negative 6, like so. Okay, very important matrix. Remember, when you substitute, you've got to substitute using brackets and put exponents on the outside. Okay, because now what's going to end up happening is that we've got negative 6 times negative 6, which gives us positive 36, is equal to negative 12a, and then we want to divide both sides by 36. Okay, so both the right and the left, and that means that a is going to be equal to negative 1 over 3. Okay, yes, Latani, at f of x, that's where the negative 12 should go. Okay, matrix, so this particular question was out of 2. There would be 1 mark for subbing in and 1 mark for your answer, like so. Okay, all right, let's go on to the final question. Omogolo, you've got a hand up. Do you want to ask something?
Ma'am, you said, does the A going to be negative or positive?
Yes.
So the answer is negative, because if in the graph is positive, the 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 equation at the top should be positive.
I'm afraid I don't understand what you're trying to ask me, Omogolo. Can you just repeat that, please?
You were asking that, is it A going to be negative or
Yes.
positive?
Yes, that's right.
I'm saying it's going to be negative, because if the graph is positive, then
Yes.
if the graph is positive, the f of x, the statement at the top should be negative, because of the graph. If the graph is positive.
Yes. Yes.
Yeah.
So yeah, absolutely. So in this case, we've worked out that it's going to be negative because we can see that it is the one arm of a sad face parabola. It's not one arm of a happy face parabola. So if we were working with a happy face parabola, we would either work with that arm over there, or they could ask us to work with this arm over here. All right, so if we saw either of those two, then we would know that the inverse also has to have a positive A value. Okay, all right, so let's go and have a look at how we are going to do the inverse here. Remember, we are dealing with the graph for f. We've got y equals minus 1 over 3x squared. So for f of minus 1, we now want to switch that around. So what was x becomes y, and what was y becomes x. Now remember, we have to make y the subject of the formula. So what I'm going to do now is I've got to divide both sides by minus 1 over 3. Or I can times both sides by negative 3. Okay, that's going to be exactly the same thing. All right, so if I divide both sides by minus 1 over 3, then I'm going to end up with negative 3x on the left, and that's going to be equal to y squared. All right, what must I not forget when I make y the subject of the formula? There's something very important that I mustn't forget. What is it? Can anybody tell me? What mustn't I forget?
Let's go, my people. I see some answers in the chat.
So y has to, so I've got to take the square root, quite right. And what do I have to remember when I take a square root? What must I never ever forget when I take a square root?
Let's go, my people.
There we go,
There we
Favor.
go.
There we go,
Well
Nolwazi.
done.
Good. Palesa, what were you going to say?
Ma'am, I'm gonna say the plus minus, but I
The
see it's
plus
in the chat.
minus. Yes, it's in the chat as well, but that's perfect. That's wonderful. Well done. Okay, so what I like to do to remind myself of this is I like to write plus minus, and then over here, I'm going to put that inside. Okay, now which one of the two is it? Is it the plus or is it the minus? Oh, excuse me. Are we choosing the plus option or are we choosing the minus option given our question? Are we choosing the plus option or the minus option? So Sandiswa says plus, Sibongenhle says minus. Okay.
Mixed answers.
Yeah, Botshepo says minus and Tlantla says minus. Mbalenhle says minus. So does Sharon. So does Nolwazi and Sarah and Olwetu. Yes, lovely guys. Okay, so it would be the minus option because the graph is sketched below the x-axis where y is negative. Okay, so the graph is sketched below the x-axis where y is negative. Okay, so we are going to choose y equals negative root minus 3x, like so. Okay, well done, everybody. Okay, so what they would want us to show here is that we've switched x and y. Here, it's out of 3 marks. Maybe there would be an accuracy mark for simplifying it like so, and then for our final answer where we chose the negative over there. Okay, let's see what you are saying in the chat. Okay. All right. So Sandiswa, you asked, please explain it again. Right. So the reason that we have chosen the negative one is because y is negative below the x-axis. All right. So if we have a look at where this function has been sketched, it's sketched in quadrant 3, where x is negative and y is negative. Okay. All right, so there we go. That's a question on the inverse of the quadratic function. Let's go and have a look at a log function now. Okay, so Sibongenhle, I see you've got a hand up.
Hi, ma'am.
Hi there, how are you?
Me.
Good, thank you. Do you have a
Okay, ma'am.
question?
Yes, ma'am. I wanted to
Go
ask
for it.
for your 4.4, would they want like a reasoning?
No, no, you
So
don't
they
have to
wouldn't want
provide
to-
any reasons there. No, no, no,
Oh,
no,
all right.
not at
Thank you,
all,
ma'am.
not at all. Okay, no problem, no problem. Okay, so let's go and have a look at the next question. Also happens to be a question 4. This also comes from an end of year NSC paper. So let's have a look at what they did to the matrix of that particular year. Now, here you can see they have not given us a diagram. All right, and this is why it's so important that we know our exponential functions and our log functions so well. All right, so if you recall from last week, okay, the graph of g of x equals half to the x. What does it look like? Can anybody describe what it looks like to me? I tell you what, let me do this. Maybe this is a little bit easier for you. Okay, so there's a set of x and y axes. So we can have a log function that looks like that. Or we can have a log function, let's pick a different color. Let's go with blue. That looks like that. Okay, so this particular exponential function, all right, is it like the pink or is it like the blue? Pink or blue? Put it in the chat. Pink or blue? What do you think? Pink or blue? Okay, so you're all saying blue. Okay, a couple of pinks. I think that's just because girls like pink. Pink, 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 pink. Oh, wow, lots of pinks. Okay. All right.
Yeah, I can tell there's more girls, or maybe it's just the right answer, but
Yeah. Okay, so if you if you said blue, then you are indeed correct. Okay, it looks like the blue. Okay, if you remember last week, I'll just quickly go back to this. Let's just jump up here to our lesson. Remember, that's where we started. Okay, we started with a recap of the exponential function. So if you have a look here, it's also drawn in blue. Okay, so it's going to be this function over here, everybody. Okay, if you remember from our lesson last week, that's what it looked like, and it's this particular function over here. So it was the decreasing exponential function that we looked at last week. All right, so that's why knowing these are so important in order to be able to answer these questions, especially in a case like this where no diagram is given. Okay, so it's like the blue one. Okay, it is a decreasing function. First question, again, this is knowledge. This is stuff that we've had to learn. They ask us to write down the range. So can anybody tell me what you think the range should be for this function? Remember, the range is our set of y values, our outputs. What do you guys think? Yes, Fahim, go for it.
Ma'am, can I just try to answer a range of G? Can I just try?
Yes,
If
of
I make a
course. And
mistake,
even if you get it wrong, it doesn't matter. Go for it.
Ma'am, I think it will be, the range of G should be what? Okay, I know it will be infinity, but then it should be y less than equal to something. I'm only suggesting, but I'm close. Maybe.
You
Maybe
are.
close.
No, absolutely.
I'm
Okay,
only
so
trying because
that's perfect. That's perfect. No problem. Okay, so as far as y is concerned, it goes all the way up to positive infinity. But when we come down to this section over here, y is approaching its asymptote, and its asymptote in this case is going to be the x-axis. So what we would have to say here, yes, absolutely, Latani, y is greater than 0. Okay, yes, Tsakofat, so you said the same thing. Okay, so y is only going to be positive. It cannot be equal to 0 because of the asymptotes. Okay, Fahim? All right. And it has to be positive. So
Thank you,
y
ma'am.
is greater
Just
than
like
0. No problem. Okay. All right. There we go. So there's our question on the range. The next thing that they want us to do is determine the equation of the inverse in the form y equals. So what sort of function is the inverse? What would we call those sorts of functions? They have a name, and we've been talking about them. Yeah, last lesson. I've said it this lesson a couple of times. Zentle, go for it.
Is it not a log function, ma'am?
It is a log function. Okay, so the inverse of the exponential function is the log function. All right, so let's have a look what you got. Yes, the logarithmic function, quite right. So now they want us to determine the equation of this function in the form y equals. Okay, so who wants to offer an answer? Can anybody tell me what you think I should be writing here? How would I do this? How would I determine the equation of this log function? Favor, go for it.
Hello, ma'am.
Hello, how are you?
I'm good, and yourself?
I'm fine, thank you, Favor. Go for it.
Ma'am, I think the answer is y equals to log 1 over 2x.
Quite right. Okay, very nice. Good job. You've done the right thing there. Okay, so what we would have to do here is that for the inverse, we would have to switch x and y around. Okay, so in other words, what we would end up with, sorry, I didn't mean to do that little line on the page, we would have ended up with x equals 2 to the y. Okay, and then we would have made y the subject to the formula and used our logs. Okay, so it's important to show our steps here. We would obviously get 1 mark for that, and for this question, interchanging x and y and then writing it in the correct form. Okay, so that was perfect. Well done, Favor. Yes, Latani saying the same thing, as is Nolwazi. Yes, Cindy, so we've got to change x and y around. Lisa, you had a hand up? Did you want to ask a question or did you want to answer a question?
I was gonna answer, ma'am.
You were going to answer. Lisa, why don't you answer question 4.3? I'm sure you know the answer.
Yeah, a function is one. Okay, let me look at it.
All right, go for it. So is the logarithmic or is the inverse a function? What do you think? Yes or no, and why?
Let's go. You can do this. Guys, let's all help Lisa on the charts.
Yes, it's a logarithm.
Yes,
It's
exactly.
a function.
Yes, it is. It is absolutely.
It's a
Sure.
one-to-one function.
Absolutely perfect. Well done. Perfect. Well done. Very nice. Okay, yes, Sharon, that's also fine to say that it passes the vertical line test is also okay. 100%. Okay, I just want to answer a question from Intlantla. Intlantla, you said, how's the base 2? The base isn't 2, it's a half. It's 1/2. Oh, sorry. Sorry. You're quite right. You're quite right. Sorry, my mistake there. There we go. Thank you very much, Intlantla. You are wide awake. Much appreciated. All right. So yes, Lisa and a few others said yes, it's a function. And again, we can say it's a one-to-one function, or we can say that it passes the vertical line test. The other thing that they would allow us to say, which is just another way of saying it's a one-to-one function, we could say that there is a unique y for every x. That's just another way of saying it's a one-to-one function, but yeah, any of those. Yes, absolutely, Zintle. So you can still say that it would pass the vertical line test, even if there is no diagram given. Okay, and they will still mark it right. Okay, I see there's some hands up, so let's just take those before we move on. Favor, did you want to ask something? No? Okay, Sandiswa?
Yes, ma'am. Can you please try to explain for me that you said, yes, it is one-to-one functions, ne? So I don't understand. How come?
Because it's a logarithmic function. So it's a one-to-one function, because for every one x, there is one y. That's why we call it a one-to-one function.
Can
Okay,
you
so
use some circles for me?
yeah, so one-to-one functions are things like straight lines. So y equals mx plus c is a one-to-one function. Your exponential function is a one-to-one function. Your logarithmic function is a one-to-one function. The hyperbola is a one-to-one function. So what that means is that for every distinct x value that we've got a unique y value. Okay, so 1x for 1y. Okay.
So if it touches y axis twice, is it not a function?
So no, that's not it, I'm afraid. So Sandiswa, if let me just scoot over. Oh, sorry, hang on a second. Let me just scoot over to the side here. All right. And if I was to draw the inverse of the hyperbola like that, this is failing the vertical line test. Okay, it's not because it's touching the y-axis twice. It's because you have one x value that has two different y values. Okay, they share the same x and they have two different y's. That's why it's not a function. Okay, so this is what we would refer to as a many-to-one relation.
Yes, ma'am.
Okay, all right, perfect. And then I think there was just one more question. Omogolo?
Ma'am, I have a question about
Sure.
the exponential function. So I just wanted you to draw a exponential function that is not a function. Like example, this one says is g negative one a function? So
Yes.
let's say maybe the answer is no. So if it's
Okay.
no, how will the graph look like?
Okay, so the answer for this cannot be no. The answer for this
Oh,
particular question cannot be no. There is not the exponential function is a one-to-one function, and its inverse is also a one-to-one function. So that's not possible in this case.
Thank you, ma'am.
Okay, no problem, Omogola. And Kozgani, if I hope I said that correctly.
Yes, ma'am. Koziani. Yeah.
Koziani. Okay, sorry, I beg your pardon. Okay, Koziani, go for it.
I have a question about the log 1.5x. Is it correct if you write negative log 2x?
Yes.
Is it the same thing?
Yes, it's the same thing. Absolutely. Absolutely.
Okay.
So that's another way. Yeah, 100%. So you can also write this as y equals negative log 2x. And you know, there's actually a third way that you can write this if you want to. And you can write this as y equals log 2 1 over x. That's also acceptable. It's not very common, but you can write it like that as well. Okay, so there's actually three ways you could write this one. Okay, but yeah, doesn't come up very often. But yeah, absolutely. Well done. Thanks for pointing that out.
Thank you, ma'am.
Good. Okay. All right. So now let's get on to some calculations. So they tell us the point M, which has an x coordinate of A and a y coordinate of 2. It lies on the inverse. It lies on the log function. They want us to calculate the value of A. All right. So any ideas as to how we're going to do this? Can anybody tell me what they think we should do in question 4.4.1? And Nhlanhla, go for it. What would you do?
Ma'am, I would substitute the values of m into the log function.
Absolutely. So tell me what I should write.
2 equals.
Keep going.
Log half.
Uh-huh.
Then x.
Okay, x or a.
A.
Yeah. It doesn't matter. All right, as long as at the end you said it was a. Okay, so a is x in this case. Beautiful. Can you tell me what you would do now in order to solve for a? So substituted beautifully. What would you do next? There we go, Nolwazi. Perfect. Are you not sure? Okay, don't stress. You know what? If you don't know, there's probably a few people that don't know how to do this. So I'm just going to put here on the side for you guys just to help you remember this. Okay, so when you have, so this is very important. So a base to the power of an exponent is equal to a number. So when you have a log, you have the exponent, and that is equal to the log base of that number. Okay, so this again, matrix, is something that you have to learn. So when you want to go from log form to exponential form, you're doing this. When you want to go from exponential form to log form, you're doing that. So this is in log form. So this over here in Nhlanhla, that 2 over there is your exponent. Okay, there's your log, the word log. There it is over there, right? And then you have your base, right? So this half over here is your base. And then let's just get another color. Let's go with purple, and then your number is the one I'm highlighting in purple. So A is going to be your number. All right, so you really did that. What you wrote here was perfect. Now we just need to go back and write it in exponential form. Okay, so what we would do is we're going to take our base, which is 1 over 2. All right, we need to raise it to the power of our exponent, which in this case is 2, and that's going to be equal to A, our number. Okay, so that means that A is going to be equal to 1 over 4. Okay. All right, so A is going to be equal to 1 over 4. Oh, Tapelo, I see you've done the same thing. You've got A is equal to 1 over 4 as well. Okay, very nice. Well done. Let's have a look if there's anything else. Yes, Nawazi, you said that too. Okay, good job. Well done. All right, everybody. Hopefully that makes sense to all of us. Chiamo, do you have a question? Go
No,
for it,
ma'am.
Chiamo.
I was gonna tell you that at g to the point at g to the power -1, I used that formula to get a.
Mm-hmm.
And
Yes,
then
that's correct.
at x, I wrote a is equals to a half to the power of 2.
Yes.
Yes, ma'am. I
Yes,
used
that's
that.
exactly it. Yeah, perfect. Perfect. That's exactly what I did as well. Okay, so A is equal to base 1/2 raised to the power of 2. Okay, perfect. So in Nhlanhla, you were the first one that got this started for us. What would happen here? It's out of 2, a mark for subbing in, and a mark for our answer in this case. All right, the next thing that they want from us is, and we would say this, now you're going to you probably haven't seen this in a long time, but this over here, we would say M prime. Okay, that's how we say that, M prime. Okay, and it is an image of M, right, that lies on G. So in other words, what they are telling us is that M is, like we had in this question over here, where R was the reflection of P in the line y equals X, it means exactly the same thing. Okay, so when they talk about point M and they talk about the image of M, they are really saying to us that these two are a reflection of one another. Okay, what they want us to do now is that if they've told us, if we know what the coordinates of M are, they now want us to work out the coordinates on the image of M, right? So just how we answered this question up here, where we switched X and Y around, it means exactly the same thing over here, right? Because we know that this point, M prime, lies on G. Okay, M was on G minus 1. Okay, so these M and M prime are a reflection of one another over the line y equals x. So that being said, can anybody tell me what they think the coordinates at M prime would be? What do you think the coordinates of M prime need to be, Matrix? There we go. All right. Chiamo, you still got your hand up from the last time, or do you want to offer an answer? Okay, so I see all of you are putting the same thing in the chat. Good, excellent. Okay, so here it would be 2 would be your x coordinate, and a quarter would be your y coordinate. Very nice. Well done, everybody. Perfect. Okay, so you can see if we can answer these questions, this question's out of 11. So if we can answer these questions, we've got 8 marks out of 11. 8 out of 11, as far as I'm concerned, is really, really good. Okay, 4.5 is going to be a little bit more difficult. All right, so in this case, they've told us if h of x is gx plus 3 plus 2, write down the coordinates of the image of M on H. All right. So in other words, what are they trying to tell us here about x of h? How is g of x related to h of x? What have they done to g to get h is what I'm asking. What did they do to g to get h? Any ideas what that means? So this kind of really goes back to functions. It's one of those sort of slightly more difficult questions. Can anybody remember what stuff like that means? Okay, I can understand why this is difficult. All right, so Favor, what do you remember?
Sharon also said yes or no?
That wasn't
Oh,
good. That's
okay, so
me.
I'm reading what Nolwazi's written, which is very nice. Let's see. Favor, go for it.
Ma'am, what I wanted to say is that isn't that a quadratic function?
No, it's not a quadratic function. It's a translation. It's a translation that's taken place.
Oh, okay, ma'am. Thank you.
Okay, no problem. Sibongenhle, what do you think?
Ma'am, I wanted to say, wasn't the graph shifted?
It was. Now, was it shifted left or right?
Okay, I'm gonna take a guess. I would say yeah, because the numbers are positive, but I say right.
Okay, so now you've made a mistake as in terms of whether it's been shifted to the right. It's actually been shifted to the left, but it has been shifted up. Okay, so I don't know if you remember this from grade 11, but when we write it in this form, they're telling us we would substitute in +3, which in effect would shift the graph to the left-hand side and not to the right-hand side. Okay, so yeah, so this is the tricky part. So I don't know if the rest of you saw what Nolwazi put in the chat. She said they shifted the graph of G 3 points to the left on X and 2 up on Y. Okay, so I can't say that any better than she has. This is an instruction to shift or translate shift G 3 units left and 2 units up. Okay, now that's not what our answer would be. That's just what they're asking us to do. Okay, so now we've got to go back and look at our coordinates of, whoopsie daisy, hang on a second, we don't want that to happen. Look at our coordinates of M prime. Okay, so that's these coordinates over here. If I was to take my X coordinate and now I'm moving my graph 3 units to the left, what is my new X coordinate going to be? What's my new X coordinate going to be? Remember, I'm working from M prime. So my new X coordinate, that's it, Nolwazi. Okay, my new X coordinate is going to be -1 because I've had to take 3 away. Good job, everybody. And what would my new Y coordinate be? What would my new Y coordinate be? Chantal, where to? You're welcome to unmute and speak. What's my new Y coordinate?
Good afternoon, ma'am. Ma'am, I raised my hand to answer the question regarding the shifting of the graph.
Oh, okay, that's fine.
Yes.
Do you know what the new Y coordinate would be?
No, ma'am.
No. Okay, so you're adding 2 onto the current Y that you've got. So at the moment, the Y coordinate at M prime is 1/4. If you add 2 onto that, what would it be? If you
It would
added
be 9/4.
it would be 9/4. Yeah, 100%. Okay, well done. It would be 9/4. Perfect.
Thank you, ma'am.
Good job. Okay, so that's a 9. It's not an A. Just make the little tail a little bit longer. Okay, yes, and I see there's a whole bunch of you that have put that in the chat as well. Good. Yes, Nolwazi, that's fine. You could write it as 2,25 if you want. You could also write it as a mixed fraction if you felt like it as well. There would be no problem with that either. Okay, Omoholo, did you want to ask something?
Ma'am, I wanted to ask, how did you get -1? Can you please show calculations?
Yes, absolutely. So in other words, what you're doing is that you're starting with your X coordinate here that I'm highlighting in pink. It's 2. And then you have to take 3 away because you had to shift it 3 units to the left. All right. And then as far as your Y is concerned, you starting here at 1/4 and you shifting it 2 units up. So you have to add 2 to Y. All right. So remember, when we move up, we add to Y. When we move down, we minus from Y. If we move to the left, we have to subtract from X. And if we move to the right, we have to add to X. Okay, when we're doing translations on the Cartesian plane. Okay, Princess, go for it. What did you want to ask?
Good afternoon, ma'am. I wanted
Afternoon.
to ask,
about if you had to substitute g of x, which is 1/2 there, and then use +3 and +2 as exponents, would it be wrong?
Just say that again, please, Princess, if you had to substitute.
G of x.
Yes.
So if you put 1/2 there and then say to the exponents of +3 in brackets +2, would it be wrong?
Yes, that would be wrong. That would be
Okay.
wrong. Yeah. Yeah.
Thank you.
Yeah. So yeah, this is not changing the exponents. This is, yeah, no, that would be wrong. Okay. You shifting the graph. Okay, good job, everybody. How are we feeling so far? Sorry, I should have asked you after the first question. How are you feeling now? Are you feeling good? Is this making sense? Is everybody happy? Thumbs up, thumbs down.
Yep, let's vote, my people. And for all worried about network load shedding, I'm also on load shedding. Okay, so just hold on. Remember, Teacher Lee and I are recording this. You will get it tomorrow. Okay, so you can watch it again.
Absolutely. Okay. Oh, that's so nice to see, guys. Oh, lovely. Mikhail, that's great. You're happy. Nawazi's happy. The rest of you, good. Angelique says, lovely. Yeah. So 4.5 is a difficult one, Lee Corner. But you know what? If you get 8 out of 5, that's also perfectly fine. Okay. Yes, we can definitely do more like this. No problem. All right. And we're going to do lots more before you write the exams too. There's going to be lots and lots and lots of revision. Okay. All right. Nice to see so many positive responses. Okay. So let's see if, I don't know if we'll be able to do all of this, but let's see if we can squeeze this one in. We might not be able to get to that last question. But let's have a look at this. All right, so this is something else. Again, it's an end of year paper that I, well, not stole, but took this question from. So this is the sort of thing that you can expect to see. I hope it's not too small. They're telling us here that we've got the graph of f of x equals log 4x, just in case that was a little bit difficult to see. And they have told us, the other bit of information is that the point B lies on the line. The x coordinate is k and the y coordinate is 2. Right. Now they're going to ask us some questions about this log function. The first thing that they're asking us is to calculate the, sorry, not the coordinate, calculate the value of k. So what do you guys think we should do in this instance? How would I calculate the value of k? What do you think I should do? Any ideas? Zinhle, what would you do?
Ma'am, I was gonna say maybe you could substitute the coordinates of B into the graph f of
Yeah,
x.
absolutely. Absolutely. So tell me, what would you write? And I'll write the same thing. What would I write? What should you write?
For f of x, I would substitute 2 and then
Lovely.
4 to the power k. Yes.
Perfect. Okay, and now you've got to work backwards from log form to exponential form. All right, so what does the number 4 represent, Zentle? What is the 4? It is our
Base.
Good. Okay, so 4 is the base. What is the 2?
The 2 is the exponent.
Beautiful. Okay, and k is our number. Lovely. Okay, so the value of k is?
Oh, you have to square root and then you'd find k is positive.
Yes, and we're not square rooting, we're squaring. So we're saying 4 squared. So we would end up with?
16.
There we go. Okay, good job. All right, so the value of k. So lovely, well done. Gain 2 marks there, 1 mark for subbing in, 1 mark for the answer. You see again, Matrix, how important it is to be able to go from log form back to exponential form. Okay, it's something that they do ask. All right, so we've got to make sure that we are able to do this. Okay, now a slightly more difficult question. They've asked us here, determine the values of x for which y is greater than or equal to -1, but smaller than or equal to 2, right? So remember, f of x represents y. So f of x is y. So another way we can write this is y has to be greater than or equal to -1, but smaller than or equal to 2. Right. So this is definitely one of those more challenging sorts of questions. That's why it is only out of 2 marks. Okay. Sorry, there's been a question. I must repeat question 6.1. Lisa, what I'm doing is I'm going from log form to exponent form. Okay, so I'll just write it here again for you. I think it would be beneficial for everybody. Okay, so in exponential form, you have your base to the power of your exponent, and that is equal to a number. That's exponential form. Log form is when your exponent is the subject of the formula, so it's equal to the log of your base and your number. Okay, so what we need to see here, Lisa, is that what you've been given here is the same as this. Okay, the 2 is the exponent, the base is 4, and k is your number. All right, so what Zintle did for us, so very nicely, was go from this form over here to that form over there. Okay, can you see how she used the base? This is the base, and she wrote the base as 4. Here, this 2 is our exponent, so she wrote it to the power of 2 is equal to k, and then she said that 4 times 4 is 16. Okay, so very nice answer. Okay, yes, now we haven't finished 6.2. Let's first talk about what 6.2 means before we start worrying about how we actually get to the answer. And what we've got in 6.1 is related to what we have in 6.2. Okay, here they are talking about y values. Okay, so that's why I was sort of pointing this thing out to you. Okay, they're talking about y values. So when y is 2, what is the value of x? So when y is 2, what is the value of x? We've just calculated it. There we go. Lovely. Okay, so here, this is what I'm asking you, right? If you look at point B over here, remember we just calculated the value of k. So when y is 2, k or x was 16. Okay, so here you've got B and your coordinates were 16 and 2. All right, so we know what this part of our inequality is going to be. Right? Because we know that when 16 went in, 2 came out. Now what we need to do is figure out what goes in to make -1 come out. How can we do that? So again, they're asking us to work backwards. When -1 comes out, what went in? So in other words, we need to solve for x when y is equal to 4. Right, because that's, sorry, not when y is equal to base 4, sorry, when y is equal to -1. Right, so we need to solve for x when y is equal to -1. So again, they're expecting us to do a very similar calculation to what we had to do for 6.1. So remember, -1 is the exponent. So if I'm going to rewrite this in exponential form, I would say that x is equal to 4 to the power of -1, which means that x would be equal to a quarter. So in other words, I have a lower bound and an upper bound. When a quarter goes in, -1 comes out. When 16 goes in, 2 comes out. So the values of x for which y is greater than or equal to -1 but smaller than or equal to 2 is when x is going to be greater than or equal to a quarter but smaller than or equal to 16. Excuse me. There we go. All right, so a few of you have got a quarter. Princess, not exactly, no. When they're asking you for which values of x will the series converge. Oh, I see what you mean where you're solving like in an inequality. Yes, I mean, it's similar in the sense that it is an inequality, but yeah, it's not a sequences and series question, it's a functions question. Okay, so that's how we would do that particular question. All right, so when y is greater than or equal to -1 but smaller than 2, it means that our x values are between a quarter and 16 included as well. Okay, all right, let's have a look. Oh, we're nearly out of time here. Let's just do this one last question and then we can do the poll. Okay, Tandlewete, you got a question?
Yes, ma'am, I have a question.
Sure.
Ma'am, for 6.2, would we have to use, or are we required to use the answer we got from 6.1? Are the questions interlinked?
Yes, the questions are interlinked. Okay, so that
Only
2 over
when it's
there
the-
and that 2 is over there. That's how I knew that this had to be 16.
Oh,
Okay, because this
okay,
16 over
okay,
here
yes.
went over there. Then I needed to find what this x was when that -1 came out. So that's why I was solving for
Okay.
x when y was equal to -1. Yeah, so yes, absolutely.
Okay.
Question 6.2. If you can't do question 6.1, then question 6.2 wouldn't be very easy either. Okay, so let's just,
Thank you,
no
ma'am.
problem, no problem. So let's just do the last one. We're writing down the equation of f to the -1 in the form. Okay, so now the inverse is the exponential function. So if we have got our original function as y equals log 4x, then it means that our inverse is going to be y is equal to our base of 4 to the power of x. Okay, and that's going to be our exponential function. Remember what we would have done here is we would have interchanged x and y. Sorry, x equals log 4y, and then we would have gone therefore y is equal to, because remember this is our exponent and this is our base. So y is our number equals 4 to the power of x. Okay, so that would have given us another 2 marks over there. So 2 marks there, a mark for interchanging, and a mark for our answer. I cannot believe we're out of time already. Yes, financial maths we will probably do later in the year. We're going to do trig next. Anyway, there's the poll. I'm going to love and leave you all, and we will see you on Thursday. Have a wonderful week, everybody.
Yeah,
Take
thank
care.
you. Thank you.
Thank you.
Ma'am.
Yeah.
I think Yolanda's
Can
going to have
you,
to answer your question, okay?
ma'am, can you please show the diagram, the last one that we didn't do? I want to do it my own.
You mean this one here?
Yes, ma'am.
Okay, so I'm going to show you that over there. And then there are the questions. Okay, so this is quite a lot more difficult, but there you go.
It's 100%, guys. Thank you. We gotta run, guys. We gotta run. Bye-bye, everybody. It was a nice lesson. Y'all learned a lot and you behaved quite well. So thank
I'm
you.
the graph. Graphs, ma'am.
Ma'am, can you just take a picture of the graph and the questions, please?
Which graph?
For question 5.
Okay, and then let me just go down to the graph. There you go.
I just leave in the
And
other
also
class.
for questions.
Yeah, Yolanda, you go and I'll join in 2 seconds.
It's fine, ma'am.
Okay, there we go. And then there were the questions. Okay.